Recording with Gautam, and guys, today we will be working on Emotion AI part 3. Sorry, part 4. So, without any further ado, let's dive in. So, what we'll be going to doing today is preparing our test data, basically data we will put into the model to see if it's accurate or not. So, first, this is what we're trying to aim for. So it shows this. And it says this is the emotion anger, this is disgust, this is sad, this is happiness, this is surprise. So that's what we're looking for. And we do a little data visualization, and then that's where we'll stop today. We'll stop at basically understanding how this works. So first, we read in the ICML face data CSV, which is basically, like we've said again, the data. And we turn this into a 90 by 90, which is basically the grayscale for each pixel. We turn this to 90 by 90, and then we get the actual face. Then in emotion, it's basically 0, 1, 2, or 3. We can clearly see here that 0 is anger, 1 is disgust, 2 is sad, 3 is happiness, and 4 is surprise. So that's the data we're working with. We have about 24,568 columns. Sorry, rows. So here's a breakdown of what each line does. So first we get everything in string format just to see the grayscale. We can see we have a lot. So this defines the function string to array that takes the string x as input. So the string x is a pixel value, and next in the function in the string splits the string into a list of individual values using the split function. Then it converts the list into a NumPy array by using np.array. You can see that here. And the array is then reshaped into a 3D array with dimensions 48, 48, and 1 using the reshape. And then finally, it is converted to a float30 float data type using the asType function. So then we take the 48 by 48 image into a 96 image as we're resizing it. So this is the function resize. The image is you reshape it, x.reshape to 48, 48. So you assume that the image is 48, 48, which is happening. Then the function reshapes the 2D array. This turns it into a 2D array. So the function reshapes the array to a 2D array using the dimensions 48, 48. It then uses the CV2 library to resize the image to a new size of 96, 96 using CV2 resize. The interpolation parameter is set to CV2.intercubic, which basically causes better image quality. So applying these functions to the data frame. So you can see that these lines apply string to array So you do string to array, and then you resize all the images. The apply method iterates through each value in the column and applies the effect. This effectively converts the pixels values from the string format to an array format, then resizes the images to 95, 95. So we went from having just string to now a list with now actual resized and different coordinates, because you turned the image from 48, 48 to 96, 96. So check the shape of the data frame. It is 24,568 rows with 2 columns, emotion and pixels. Then you check if the data is empty, making sure that we have no empty values. Then you define the label mapping, which is basically the line defines a dictionary called label to text that maps numerical labels corresponding to the emotion text. So 0 is now anger, and then 1 is disgust, 2 is sad, 3 is happiness, 4 is surprise. So we're using PLT. We use PLT, and we take the first image. We use the pixels. We take the first image from the data frame. We take the pixels columns, and then we plot it using the grayscale. So we can see that is the image. You can see the pixels here and how it's been put together. So displaying images by emotion. So this code iterates through a list of emotions. For each emotion, it filters through facial expression DF to select the first image of that emotion. So you can see that we index through what emotion and when and then basically see which is the first. Then you You extract the image array and selected row and reships to 9696. Then you plot it with the label and you just use the same upgrade. So you can see that this is the first instance of anger we can see, first instance of disgust, first instance of sad, first instance of happiness, and first instance of surprise. So then we just put the DF emotion value counts and the index. So we have index 3, 0, 2, 1, 0, 1, 2, 3, 4, which is basically this. Then we just plot figure a 10 by 10 using Seaborn, which is a bar. Then your bar plot basically shows what you value count the emotions of the facial expression DF, and on the X, yeah, so basically on the X it's the emotion like 0, 1, 2, 3, 4, and on the count it's 0 to 8,000. So using this as reference, let me just copy this real quick. Using this as reference, we can see that there is not a lot of disgust, but there is a lot of happiness and a lot of sadness compared to surprise, anger, and disgust. So this can just basically help us understand like what data are we playing it. If it's not able to identify disgust very accurately, you can see that it's because of a lack of data. If it's not able to define happiness accurately, we can see that it's a problem with the model. Then you split the data frame into features. You use Keras Utils. Then X is the pixels, Y is the emotion. Basically, you turn into that, the Y, X. And yeah, so this is it, guys. We basically, what we did in this video on this lesson today was we took this new data set. We used the reshape and resize function using CV2, NumPy, and their functions to upsize the image quality and to apply this to all values in the data frame. Then we made sure nothing's empty and that the data frame is still good. Identified the emotions, plotted the emotions with their corresponding image, and then checked to see how much of each emotion is there. Then this will aid us in the next episode. Thank you guys for watching. Don't forget to share, like, and subscribe. This is Coding with Gautam, and I'll see you next time. Have a great day.